Test 6 review covering Module 6 of inverse and radical functions. Question 1 and 2. Use f of x equaling 2x and g of x equaling negative 4x plus 5 to find the following. So questions 1 and 2 is going to deal with all four of these. So the first one, we're going to be adding the functions. So we're having f of x and g of x. So f of x is 2x and g of x is plus a negative 4x plus 5. Now for this one, just add like terms and we get an answer of negative 2x plus 5. Next one, we're going to subtract the functions. So I have 2x minus, and it's important to put the second function in parentheses because I'm subtracting all of that. So that's a minus 4x plus 5. So when I'm subtracting a binomial or the set of parentheses, I'm really distributing the negative 1. So it's really 2x plus 4x minus 5. When I combine like terms, that gives us 6x minus 5. The next one, we're going to be multiplying the functions. So I have 2x times a negative 4x plus 5. And I'm going to distribute the 2x. So that gives us negative 8x squared. And 2x times 5 is a positive 10x. And the last one, we're going to divide the functions. So we have 2x on the top, and we're going to divide negative 4x plus 5. We can't have it, there isn't any common factor in the numerator and denominator, so we can't factor it any further or reduce it any further. So that part is our answer. But because I have a variable in the denominator, I have to make sure that whatever the value is for x, it can't make the denominator equal to 0. So I'm going to take the denominator in the denominator and make it equal to 0. And I'm going to solve for x. So I'm going to subtract 5. I have negative 4x equaling a negative 5. Divide by negative 4. When x is equal to 5/4, the denominator is 0. So that means I have to put in my answer that x cannot be 5/4. Question 3. If f of x equaling 3x and g of x equaling x plus 4 and h of x equals x squared minus 1, find the value. So these are all composing functions. So you always start from the far right and move to your left. So they're telling me find f of g of 1. So they're telling me put 1 in for x for g of x. So that's what I'm going to do here. So I'm going to put a 1 where x is in g of x and add 4. And that gives me 5. So if g of 1 is 5, I now have to find f of 5. So I'm putting the answer of what I got for the g of 1 in for the x of f of x. So that means I'm going to go to f of x, which is 3 times x, but instead of the x, I'm going to put a 5 in here, and I'm going to get an answer of 15. The second one is another way of writing a composition of functions. This one is saying h of f of g of 3. So they're telling me start on the inside, or the far right hand side, and I'm going to put 3 in for x of g of x. So when I do that, I have 3 plus 4, which gives me 7. Now they're telling me to take that 7 and put that into x of f of x. So f of x, it would be 3 times 7, which is going to give us 21. And now they want us to take that 21 and put that in for x and h of x. So it's really h of 21 equals 21 squared minus 1. And 21 squared is 441 minus 1 gives us 440. So our answer to this composition of functions would be 440. Question 4. Find f of g of x and g of f of x. and then determine, are they inverses of each other? So for f of g of x, when I put g of x in for x of f of x, I get negative 3 times negative x plus 8. And when I distribute the negative 3, I'm left with 3x minus 24. And if I do g of f of x, and I simplify that, I would put negative 3x in for x of the other function, so it would be a negative, and then in for x, I put negative 3x, and then I have plus 8, and this is going to give us 3x plus 8. Now they're close, but they're not the exact same. They don't give me the same value at the end, and they don't give me just plain x at the end. So when you do composition of functions, if all you have left is x, they are inverses of each other. Since I don't have those, these are not inverses. Question 5. Use composition of functions to prove that f of x equaling 8x minus 10 and g of x equaling 1/8 x plus 5/4 are inverses. Now you could solve these another way, but I'm going to show you how to do the composition of functions here. So if I want to do f of g of x, I'm going to put 1/8 x plus 5/4 in for x here. So I would have 8 times 1/8 x plus 5/4, and on the outside I have minus 10. So I distribute, that's going to give me x. 8 times 5 is 40, 40 divided by 4 is 10. Then I have minus 10, which gives me an x. So far that looks good to be inverses. Now what about the other way? What if I put g of f of x? I would put 8x minus 10 in for x of g of x. So this would be 1/8 times 8x minus 10. And on the outside I have plus 5/4. And if I distribute the 1/8, that gives me an x. And negative 10 divided by 8 would give us a negative 5/4 plus 5/4 gives us x. So that is proof that they are inverses. Now another way you could have done it is if I took one of these functions and switched my x and y around, I would have x equaling 8y minus 10, and I would solve for y. So if I add 10 to both sides, I have x plus 10 equals 8y. Divide everything by 8. I'm now left with y equaling 1/8 x plus, if I divide the top and bottom by 2, I'm left with 5/4, which is what I have in the other function. So that's just another way to prove if the two functions are inverses of each other. Question 6, find the inverse of f of x equaling x minus 4, and then graph the function and the inverse on the coordinate plane. So again, I'm going to switch my x and y around. So it's going to be x equaling y minus 4. And then I'm just going to subtract, or I'm just going to get y by itself by adding 4 to both sides. And the inverse would be y equals x plus 4. You could also write it as f to the negative first of x equaling x plus 4. So I'm going to plot that one first on my graph. So it crosses the x or the y-axis at 4. So 1, 2, 3, 4. I have a positive slope, so up 1 over 1. So this line would go up like this. And the original one would be x minus 4, so it crosses the y-axis at negative 4. Also has a positive slope of 1, so this one would look like this. So the red is the inverse of the blue. Question 7. Identify the domain and range of the radical function, f of x equaling negative square root of x minus 2 plus 3. Now to find the domain and range, the domain is what are all the possible x values you can use. Well, if I have a radical, I can't find the square root of a negative number. So one way to find this is just take the radicand, which is x minus 2, and it has to be greater than or equal to 0. So I'm going to make this greater than or equal to 0, and then I'm going to solve for x. I'm going to add 2 to both sides, and I'm left with x is greater than or equal to 2. So that would be my domain. The domain has to be greater than or equal to 2. Now the y value, our range is, I'm going to put that value in. So the lowest number, the lowest x value I can put in here is 2. So if I put 2 in for x, 2 minus 2 is 0. The square root of 0 is 0. Times negative 1 is still 0. 0 plus 3 is 3. So I know it's not going to go lower. Oh, so let me just do that. We could easily draw a table of values here. So if I put 2 in here, I get 3. Now if I put a, say I put a 3 in for x, 3 minus 2 is 1. The square root of 1 is 1, times a negative 1 is negative 1. Negative 1 plus 3 is 2. So that means my y value is going to be below 3. So I would have a range of y is less than or equal to 3. And it's less than or equal to because I have this negative sign out here. If you don't see a negative outside there, then it's always going to be greater than or equal to whatever the whatever this starting point would be. So that is one way you can do it. You could also put this on your graphing calculator and find to graph that function, and you can see using the table features where the domain and range would be. Question 8. Simplify the following. So when you simplify exponentials, number 1, you can't have negative exponents. Number 2, you can't have fractional exponents in the denominator of your base. So let's look at this first one. We have d to the negative 2/5. So anytime we have a negative exponent, we have to flip the base. So the reciprocal of d is 1 over d, but then I have to raise that to the positive 2/5. But you'll notice I now have a fractional exponent in the denominator, and I can't have that. So to get rid of it, I'm going to multiply this by a exponential that's going to give me an integer. So if I multiply this by d to the 3/5, and the reason why I'm multiplying by 3/5 is because when I multiply like bases, I add the exponents. And 2/5 plus 3/5 is 5/5. And 5/5 is the same as 1. So that means I would have d to the first power in the denominator. But whatever I do in the denominator, I have to do the exact same thing in the numerator. So I'm going to multiply the top by 3/5. And 1 times d to the 3/5 is d to the 3/5. And this would be my final answer. And if you want to verify it, if I did d to the 3/5 divided by d to the 5/5, I end up with d to the negative 2/5 is what we started with. So it's just simplifying it without having negative exponents or fractional exponents in the denominator. The second one, I have like bases, and when I have like bases and I'm dividing like bases, I take my exponents and I subtract them. So I'm subtracting 3/5 and 1/2. So I need common denominators, and the common denominator is 10. So I would have c to the 10th. So I'd multiply this by 2 halves, which would give us 6/10, minus this I would multiply by 5/5, and I would get 5/10, which would give us an answer of c to the 1/10. And that would be our solution. Question 9, simplify the following here. When I multiply like bases again, I add the exponents, which this is going to give us x to the 12/3, and 12 divided by 3 is 4, so I would have x to the 4th. This next one, when I raise a power to a power, I multiply the exponents, so this will give us 6/12, which would be x to the 1/2 power. And question 10, write the simplified form of this expression here. Here I'm going to have to use the conjugate because I can't have radicals in the denominator. So if I multiply by the conjugate would be 4 square root of 5, not minus 4, but plus 4. And I'm going to do that in the numerator as well. And we're doing that so we can get rid of the radical in the denominator. So now down here, just treat this like a difference of two squares. If I take the first two terms and multiply them, that gives me 16, and the square root of 5 times the square root of 5 is 5. And then the negative 4 times a positive 4 is a negative 16. You can always FOIL it, but this is just a shortcut of doing that. So 16 times 5 is 80, and 80 minus 16 would give us 64. Just want to verify that quickly. So 16 times 5 minus 16 gives us an answer of 64. Now in the numerator, I just distribute the 6, so that's going to give us 24x square root of 5 plus 24x. So right now I have 24x square root of 5 plus 24x all over 64. Now I can take an 8 out of the numerator and the denominator. So this would be like 8 times 3x square root of 5 plus 3x. All this divided by, I can take an 8 out, and I have an 8 left over. The 8's divide out, so my final answer would be 3x square root of 5 plus 3x, all divided by 8. Question 11. Write the simplified form of the following. Here, so we're going to add and subtract like radicals. But in order to do that, I need to break down the radicals. So this would be the square root of 9 times the square root of 2x. And that would be simplified to 3 times the square root of 2x. This one, I can simplify this to the square root of 4 times the square root of 7. Square root of 4 is 2. 2 times 5 is 10 square root of 7. This one, I can simplify this as the square root of 49 times the square root of 2x. And the square root of 49 is 7. 7 times 3 is 21 times the square root of 2x. And this one I can't simplify any further, so that would be 3 square root of 7x. Now I have a square root of 2x and a square root of 2x here, so I take my radicals, or my coefficients of 3 and 21 and subtract them, and I get negative 18 square root of 2x. And then I have a minus 10 square root of 7 plus 3 square root of 7x. There's no like radicals left over, so this would be my final answer. Question 12, I need to break these down. So I would have the 4th root of 4 times the 4th root of x to the 5th times the 4th root of y to the 20th. Now I can't find the 4th root of 4, so that stays put. Here I can get one group of 4 out of 5, so that gives me 1x, and that leaves me with 1 4th root of x left over. And a quick way of doing it is just doing 5 divided by 4, and it goes in 1, and you have 1 remainder. So 1 on the outside as an exponent, 1 on the inside. And here, 20 divided by 4 is 5, so that would be y to the 5th. So all these parts that I circle, it would be in my answer. So my answer would be x, y to the 5th, times the 4th root of 4x. And that would be my simplified answer of that expression. Question 13. Here we're going to multiply radicals, so I'm going to FOIL this. So I have square root of 3 times 2 square root of 3, square root of 2, which will give me 2 square root of 6. Square root of 3 times 4 square root of 3, which will give us a positive 4 times 3, because square root of 3 times square root of 3 is 3. Next part, distribute this square root of 2. So this will give us a minus 2 times the square root of 2 times square root of 2 is 2. And square root of negative 2 times, or square root of 2 times 4 square root of 3 is a negative 4 square root of 6. And when I combine like terms, I end up with a negative 2 square root of 6 because this part and this part combine. And then I am left with these two parts, which is 12 minus 4, which is a positive 8. And this would be my final answer. Let me make this 8 a little bit better. So here's our final answer for that one. And question 14, we are we're subtracting radicals here. Break these apart. I gotta think of perfect squares I can get out of 175. So let's try 175 divided by 25, because 25 is a perfect square, and I get 7. So this would be the square root of 25 and the square root of 7a. This one here, 112, let's see, 112, I think 16 might work in that, so let's try that. 112 divided by 16, and I get 7. So this would be the square root of 16 times the square root of 7a. This one, square root of 9 and the square root of 7a. From that point, let's simplify it. This is 5. 5 times 10 is 50. Square root of 7a minus square root of 16 is 4. 4 times 4 is 16 times the square root of 7a. Square root of 9 is 3. 3 times 2 is 6. Square root of 7a. Since they all have square root of 7a, I can take my numbers and subtract them. So on our calculator, let's do 50 minus 16 minus 6, and we get an answer of 28. So 28 square root of 7a. Make sure you keep that radical in there. Don't take those out. And our final question, question 15, solve the following. Here we have a radical, but they put it in an exponential form. If you want to keep it here, you can, or you can write it this way, 3 times the square, like the cube root of x plus 5 minus 6 equaling 0. We want to get the radicand by itself, so I'm going to add 6 to both sides. Now I have 3 times the cube root of x plus 5 equals 6 divided by 3. I now have the cubed root of x plus 5 equals 2. Now to undo a cube root, I cube that side, but I have to cube the other side to keep them balanced. And that gives me x plus 5 equals 8. To get x by itself, I'm going to subtract 5. And I'm left with x equaling 3. Now we would just want to verify that it works. So if I put 3 back in for x, 3 plus 5 is 8. The cube root of 8 is 2. 2 times 3 is 6. 6 minus 6 is 0. So 3 would be an acceptable answer. So that is how you can review, or questions you can review on inverses and finding radical functions.